Okay, this is a static equilibrium problem. That means that the net force is zero and the net torque is zero. In fact, I'm going to write those right over here. Very important. So net force is zero. I'm even going to split that up into net force in the x direction is zero, net force in the y direction is zero, and this is new, net torque is zero. Okay? We're going to use this for any problem where you've got a situation where the object is not moving and it's going to continue to not move. So furniture, buildings, bridges, stuff like that. You don't want them to fall or collapse or rotate. They just sit there. The first thing we need to do is we need to identify the forces that are acting on the tabletop, because eventually my goal is I want to find the force of this leg pushing up on the tabletop. So this, come on. So this force right here, I want to know that. I'm going to call that F1. And I want to know the force of this leg pushing up on the tabletop. We're going to call that F2. Okay, I don't know what those are. I want to know them. Well, I also have this box pushing down on the tabletop with its weight. So that's 20 kilograms times 9.8 meters per second squared, which comes out to 196 newtons. Boop. And the force of gravity is acting on the tabletop itself with a force of 30 kilograms times 9.8 meters per second squared. That is going to be, 294 newtons. And that is going to act on the center of mass of the tabletop. Okay, so the tabletop is 6 meters long in total. I'm going to put the center of mass is right in the center. We can assume that this tabletop is, boy, that just won't go away. We can assume that this tabletop is uniform density and shape, even though I didn't do a great job drawing it. And if we do that, the center of mass is just in the center. And I can pretend that all the mass is right at that place, therefore gravity would pull on that spot with its weight. Okay, so the next step is, I have some choices. Pretty much all three of these things are true, so I could use any of them, fill in what I do know, and then use them to solve for unknowns. Well, if I fill in the x direction stuff, there are no forces in the x direction, so I end up with like 0 equals 0, which is true but not useful. Okay, I could use this one. Let's go try that one out. We'll do it over here. I could do net force in the y direction equals 0, in which case I've got F1 up in the y direction, so that's going to be positive. I've got 196 down in the y direction, so that's going to be negative. I've got 294 in down, so that's going to be negative. I've got F2 up, so that'll be positive, and all of that should equal 0. I'm leaving the units off just because, well, I'm in a hurry and I think I'm going to run out of room anyways, so we'll just remember those are newtons. Okay. Well, I can't really solve for F1 or F2 with this. I have two unknowns in one equation, which says to me I just need another equation. But luckily, I've got another equation I can use. I can use this one. I can use net torque equals 0. The thing about torque, though, is torque requires that I am measuring a distance from a pivot point to where a force is applied, which means I need a pivot point. There is no obvious pivot point because this thing isn't actually rotating or isn't going to rotate. If there's no obvious pivot point, that means that all pivot points must have a net torque of 0, which means I can pick any pivot point I want. So I could pick, well, frankly, anything, but I probably want to pick a place where I know distances from that place. So basically my choices are here where F1 is acting, or here where the 196 is acting, or right here, basically, or the other end of the table. I know distances to all the other things from all 5 of those places. Any of them will work, actually, and we just need to pick one. It really does not matter which one we pick. So, but I'm going to pick this one just because, I don't know, if I have a choice, I would like to pick a place where one of the unknowns is acting. And you'll see why in a second. Let me show you why. Okay, I'll show you why in a second. First, I need the general equation for torque. So the torque due to one force is equal to the magnitude of that force times how far it is from the pivot point times the sine of the angle between the force and radius vectors. Well, luckily here, like if this is my pivot and the thing I'm caring about is a tabletop, then my radius like runs right along. Oops, come on. No, I keeps doing that. My radius runs right along the tabletop, which is basically the x-axis. And all my forces are in the y-axis. That means all of these things are nice, beautiful 90-degree angles. And the sine of 90 is 1. So basically this is a 1. Which means for all of these forces, I can go ahead and simplify this to just torque equals force times distance from the pivot. Okay, so going back over here, I want to fill in the net torque, that is the left-hand side of this equation, with all of the torques that are happening to this tabletop from this pivot point. So I'm going to do force times distance from pivot for each of these 4 forces. So I've got F1. Its distance from the pivot is 0 because it's on the pivot, plus 196. That is a distance of 2 meters from the pivot. But if we go and check that out, this is creating a negative torque because if this force was all by itself, it would cause this tabletop to rotate in the clockwise direction, which conventionally is the negative direction. So actually there should be a negative in front of this term right here. Okay, plus next force 294. This one, I don't have this distance labeled, but it's not too hard to figure out. The whole tabletop is 3 meters long, or sorry, 6, I got ahead of myself, 6 meters long, which means the middle is 3 meters from the end. So this is 3 meters from the end. This also would cause the tabletop to rotate clockwise, so this is a negative torque, plus F2 is happening 4 meters from the pivot, and I'm about out of room. That's the end, so that equals 0. Okay, so here's why this was a good place to pick our pivot. If this is F1 times 0, well, this whole term is just 0, which means all I've got is, this is a number, and there's my one unknown. I got one unknown and one equation. I can solve for the unknown really easily. And if I do, okay, if I do, it comes out to 318.5 newtons. I'm totally ignoring sig figs here, just don't even worry about it. Okay, well, now that I've got that, I could take this and stick it in here for F2 and solve for F1, and it gives me F1 is 171.5 newtons. Okay, and those are the answers I wanted. That's the end of it. But I just want to point out some other choices we could have made. For instance, this particular problem, we didn't need Fx, and we used Fy instead. But some other problems you might need both of them. Maybe that's all you need. You wouldn't need any torque. Maybe you might need all 3 of them. A lot of the time, you can do a whole problem just by using this last one about the torque, but using multiple pivot points. For instance, by using the pivot point being on the far left, I was able to solve for F2 directly. I just one equation, one unknown. I could have done something similar if I had picked another pivot point here where F2 is happening, because that would get rid of F2 and just leave F1 solvable. In fact, you know what? Let's do that really fast. You can stop the video if you don't care, okay? But if I do the net torque equals 0 for the orange pivot, what I get is F1 is happening, and it is happening 4 meters away from our new pivot. And just to check, if this is the pivot and I'm pulling up on the left-hand side, that's going to make the whole table rotate clockwise, so this is actually a negative torque. Okay, plus, I got my 196. This is happening, let me see, from here to here is 4, from here to here is 2, so from here to here should be also 2, so it's happening 2 away. However, this one, pulling on the left-hand side of the pivot down, would make it rotate counterclockwise, so that's a positive torque, plus 294. This is happening, let's see, this is 3 away, this is 4 away from the end, so this is 1 meter, so it's happening 1 meter away from this pivot. And this is also a positive torque, plus F2 is right on top of the pivot, so 0 equals 0. So this is 0, and the only unknown I have is F1. If I solve this for F1, I should still get this. I just get it directly right away. Okay, so pretty much all problems could be solved in this fashion, but there's a lot of choices. You've got these 3 things to choose from, and then if you use this one, you furthermore have choices. You can put the pivot pretty much anywhere you want. So think about it for a minute before you choose one, and pick one that's nice.